Hey, hello. Welcome to my YouTube channel. It's Ranjan. This is Artificial Intelligence Machine Learning playlist, and today I will share my professional experience and will talk about complete life cycle of data science, machine learning in this particular video. And I hope you are aware about what is machine learning, data science and artificial intelligence. If you are not aware, then check out this video. So now these days we are using ML and DS collectively referring to the same thing. So let's start this video without wasting any further time. So first of all, what is the life cycle? So life cycle is basically a collection of steps which is going round and round. So it is just like a flow chart in which I will show a couple of steps in ordered manner. So they are arranged in some order. So some of us will refer this to a pipeline. Every block is a pipeline or is a step. Someone will say it's a step or it's a pipeline. So basically life cycle, this is a life cycle of data science. A life cycle is basically integrating all steps or integrating all pipelines in some fixed order. And when you will search the life cycle of data science in the Google, you will come across numerous examples of life cycle. So every example is right, nothing is wrong. Each individual explains in his own way. So it depends upon individuals to individuals, organization to organization. About this video, I'm sharing my professional experience, how it does in my organization. Every life cycle which you will search in the Google, result would be same. It would be little difference. So first step in the life cycle is business understanding, data understanding. Basically these are the two terms, business understanding and data understanding. Here I cover some main points which will come under business understanding and data understanding. So first of all, whenever a new project comes in our organization or in any organization, so first of all we try to understand the nature of the business, like in which sector they deal, whether it's IT, it is telecom, logistic, aviation, hospitality, retail, marketing, or pharmaceutical. So it could be in any domain. So generally there multiple conference call takes place with all stakeholders, all client. If we have domain expertise, like the client is from telecom or is from logistic, and we have someone who is domain expertise in the logistics, so we will try to include that person in that call. And basically this call takes place with the high senior official, senior management. On these calls we just note down all the requirements, what the customer is looking for, what client is looking for, and what we are looking for, like in terms of input, raw data, features, or what support we would be requiring from their infrastructure team. What is the goal, whether they want to predict something or they want to analyze something which has happened in the past, or do they want to change something, whether they want prescription from us, which way they do so their profit would be increased, or suppose it could be in any other, it could be like they are looking for the anomaly detection, they are looking for the frauds in banking system. Then we will discuss about the final deployment, whether they will deploy on premises or they will deploy in cloud. This is cloud. It could be online or offline learning, like suppose in case of transaction, banking transaction, that would be online. Machine learning model should support online learning. And UAT, user acceptance test, once model is deployed, which way they will perform user acceptance testing, and what would be the timelines, deadline of this project. And after that we will read all the document the customer has provided, client has provided, and what are the standard operating procedure, and we will go all through these things. And once we have all the details, then we will go to the step 2 or pipeline 2. So second step and second pipeline is in this life cycle, we have data collection integration. So first we have to consider what is the type of the data the customer will provide, whether it is structured data or the unstructured data. Mostly in the businesses or in organization, we receive the unstructured data, we have to make them structured. And what would it be, the offline data or online data? Offline data, the data has already been generated, or online data, whether they will generate the data through the online. Would be the source of the data, whether they will provide the data is stored on the premises, on their data centers, or data is stored on the cloud. Then we have to collect from the cloud. It could be a S3 bucket in the Amazon Azure, data lake, data warehouses, big data. It could be anywhere, and we have to get the data. And we have to consider size of the data, because according to the size of the data we have to select the machine learning algorithm. And would it be the small data, would it be the big data, and what would be the format of the data, whether it is in SDF5 or is in Excel or is in CVS, and whether we can transport the data it on our premises or we have to fetch the data from their premises only. Because some cases, like in finance, in banking system, they don't provide the data, they say fetch from our system, and you have to use their VPN, their network, to just fetch the data, and you cannot take the data, you cannot transport the data to our system, our on premises. And that all the process is data ingestion. We will collect the data from all the sources and will place all the data at one end. Could be our end or it could be customer end. It depends upon the requirement, it depends upon the client to client. And we will use the integration tool, where there are bots, ETL, extract, transform, load. There are many tools. And in data integration and data placing the data at one end, we will take help from data architect and data engineering team. And once we have the data collected at the one end, then we will go to the step 3. So basically it's a very important process, data pre-processing, and it takes most of the time. Like in some cases it takes 60% of the total time which we need to develop the model. Very time taking process. So first of all, we have to convert the unstructured data in the structured format. We have to organize in the table, rows and column in very structured format. And after that, we need to clean the data. We have to remove the unwanted characters, special characters, and we have to convert all the characters into lower. Suppose in case of name, and in many cases we have upper cases, so we'll convert all characters into the lowercase character. We will remove the duplicate rows because it is not required. If that is duplicate, we will remove the missing values. We will do imputation here. There are many methods imputation, I have covered already in another video. And we will remove the outliers. Either we will remove or we will fix the outliers. We will unity code. We will convert whole data in one format and removing zeros value, because in some cases we don't need zero value. Suppose we have one column which is age 0, so age could not be a 0, so we will remove the 0, or we will take the mean, median, mode of that column. We will impute the 0 value. Then we will rounding off. Suppose there are in decimal, there are many things in the decimal. We will round off to the 10 or 9. Then we will format the data in one format. We will repair the data, and during this process, when we are doing this, we will maintain what we have done. We will make version control of data, auditing, daily auditing, maintaining data, and code review. Because to perform all these things, we have to perform conferences, we have to perform code reviews by taking suggestion from everyone. And in my time when I was preparing for the data science, I have just make this a short term CD mouse. So just to remember, like cleaning duplicate CD, duplicate, missing values, outliers, unicode, zeros value. So it's just a trick to remember the data processing, but all the main points. And once we have pre-processed the data, then we will go to the step 4, which is fourth pipeline, feature engineering. Feature engineering is an art, no one can learn. It's we have to, it comes by practice and practice. So I have also prepared one short term, TDSOEINENG. So it's a trick to remember. So what is feature engineering? Basically, we are playing with the features, we are deriving new features, and we are converting the features in that way that machine learning model can accept the data. So we have to convert the features in the more acceptable format. So there are many techniques in feature engineering. So first of all, we have data transformation. And data transformation means if there is skewness in the data, or there is kurtosis in the data, or there is heteroscedasticity in the data. I have already covered homoscedasticity and heteroscedasticity in other video. This is the link. You can go check out this video. If there is skewness in data, we can use normalization of the data. If there is heteroscedasticity, we can take the logarithmic log of the input variables. We can use 1 by x, reciprocal, square root of x, exponential of x. These all the techniques of data transformation. Then we can do discretization. It is like binning. Suppose there are many rows, we will make some groups. Suppose there are age 26, 27, 28, 29, 30. Suppose in every age there are many numbers, many rows. So what we will do, we will make the binnings 25 to 30, 30 to 35. So this is like binning. In this we are doing discretization. There are many methods. We can use equal frequency discretization, equal length discretization, and scaling. Scaling is required when we have different features and they all are on different scale. Then we need to do scaling. I have covered the standardization and scaling in this video. You can check the link. Then after, there is one hot encoding. It's suppose we have categorical variables. So we have to convert categorical variables into numeric variables, because machine learning algorithm does not understand categorical variables. They all understand is numeric number. So we have to convert the categorical variables into numeric variables. So we have the technique one hot encoding, and we can create dummy variables, that is get dummies. There is a one function in the pandas which is pd dot get dummies. And suppose there are rare variables where we have very less values and imbalanced data set. If we have imbalanced data set, then we have to remove that imbalancing thing. We have to neutralize the minority and majority cases. Suppose in case of credit card fraud or any defaulter, we have less number of frauds in real life comparatively. Like if we will compare, like suppose if we have 1 lakh data, so in 1 lakh data we would have maximum 1% of fraud. So in that case, if we will take 1 lakh observation in which we have only 1% of fraud to the model, so model would be biased. It every time it will model will mark this new data as not default, not fraud, because it would be biased towards the non-fraud data, because fraud is only 1. So we have to make the data balance. So there are many algorithms like smart, smart to max, smart teen. It is synthetic minority oversampling techniques. It's a 2mac links. We are combining, we are using smart plus 2mac, and here we are combining smart plus nearest neighbor. These are the techniques for oversampling or undersampling. Basically, we are oversampling the minority class, or it could be any other way. Undersampling means we will undersample the majority cases, and this is extracting features. So it could be used in NLP when we have text. So we have to extract the feature from the text. In the upcoming videos I will cover these things, NLP. So there are many techniques extract the feature from the text, like bag of words, TF-ID, term frequency, inverse document frequency, n-grams, word to vectorization, topic extraction. So these all will come in NLP, and we can create some new features, new columns by using the domain expertise knowledge. We can derive new features from ourselves, or by combining some available features, or we can go by internet some what could be the feature in this domain. So we will ask that feature whether the customer have that feature, customer have that advanced column or advanced feature. And after that, once we have completed the feature engineering, that we will perform the statistical and graphical data analysis. So basically we will convert the data into the graphs, what exactly data is saying, because a picture say 1,000 words rather than the text, because a picture says 1,000 words as comparable with the text. Because if we will see the data, we will understand nothing, but if we will see graph, we will understand that yeah, data is saying this, data is saying thing. And for this we can use many tools. Like in terms of GUI tools, we can use Tableau, we can use ClickSense, we can use Power BI, we can use Excel, and there are many other tools. And in terms of Python libraries, we can use Pandas, Seaborn, Matplotlib, Plotly, Cuffly. I will be covering these topics in my upcoming videos. And once we have completed this step, this pipeline, fourth pipeline, we will go to fifth pipeline. This is very important pipeline we have, because we in general environment, in official environment, in practical life, we have many features. We could have 40 features, 100 features, 120, and after applying one hot encoding and dummy variables, this number can go up to 200 or it beyond 200. So we have to convert many features into important feature. We have to consider these many features, and we have to select some important features, like 5 features, 10 features, 15 features. We cannot go beyond this. So there are many techniques to select these features, which are the important features, because we have a term like garbage in, garbage out. If we will feed the garbage to the model, the output will always be garbage. So we can use the correlation between the independent variable and the dependent variable, whether they are correlation, whether there is a correlation or not. It could be negative or positive, but there should be some correlation. We can use heat matrix. It's a technique for representing the correlation between all the independent variables. And we can use a multi-collinearity check, whether all independent variables are strongly correlated with each other or not. If they are strongly correlated with each other, then we have to drop one variable, or we can combine those independent variables. There should not be strong correlation between among these independent variables, because it will create a bias. And we can use ridge regression to reduce this multicollinearity. And we have the backward elimination to select the important features. If the p-value is coming less than 0.05, then the feature is important, otherwise we will drop that feature. And we have technique PCA, that is principal component analysis, or we can use NMF. NMF is basically a non-negative matrix factorization. I will be covering this topic in my upcoming videos. And we can use ICA, independent component analysis. These all techniques will come in sklearn library. sklearn is very famous library for machine learning problems. So we have ICA and fast ICA. ICA is independent component analysis, and this is fast independent component analysis. Then we have the SVD, singular value decomposition. These are all the techniques for the feature selection. Once we have implemented the feature selection, then we will go to the graphical analysis again, using by all tools, GUI tools or Python based tools like Pandas, Plotly, Cuffly, Matplotlib. Then there is a sixth step, which is model creation. And on the basis of the EDA that we have performed in the feature selection in feature engineering, we will select some algorithms. So basically there is a term which is free lunch theorem. It states that no model is work well for every problem. So it happens like linear regression would work for one particular type of problem. So lasso regression, there is no such thing that this model is work for every problem. So we have to try each and every model and we have to see the results. And machine learning is all about experiment. We have to do experiment, then we can see the results. We have to tune that thing so we can get the better result. So generally we consider 5 to 6 models, 7 model, 8 model, 10 model. It number could go anywhere because it all depends upon the accuracy. If we are not getting the accuracy, we have to research, we have to use another model. So there are three kinds of problem: regression, classification, anomaly detection. If that is regression case, first we will try linear. If we are getting good accuracy in linear, we will try lasso. If lasso is giving not good accuracy, we can try another model. If that is giving enough accuracy, we can be with the linear. If accuracy is more concerned, then we will try another model, random forest classifier, but takes much time in training. So basically we can go AdaBoost regressor, XGBoost regressor, but XGBoost takes much time to get trained. So if time is the concern, we can go with these things if we are getting the good accuracy. And if it is case of classification, we can go logistic, SVC, naive bias, random classifier, AdaBoost classifier, light GBM and cat GBM. These models are getting very used now these days. And suppose if a case of anomaly detection, we can use isolation, forest, logistics, and local outlier factor. And once we have created number of models, then we will go to the model validation. So basically model validation is about you have selected number of models, we will validate each and every model, then we have to come to the conclusion that this model is performing very good. We will apply cross validation on all the model that we have selected and we will see the result which is giving good accuracy. And there are three terms: time, effort, and resources. We have to consider these three things while creating the model, because if time is concerned, like how much time it is getting to train the model, and how much efforts, whether we have the available time, whether we have the deadline, so how much effort we can give it, and what are the resources, like whether it is computational expensive. We have to take these three things in the consideration. And we have to consider the trade-off between the bias and variance. This is bias. So basically bias and variance, it is underfitting and overfitting. So we have to select a sweet spot in between bias and variance. True positive, same as it between true positive and true negative. Suppose the client is more interested to get the true positive accurate. If true positive will get increased, so true negative will decrease. So there is a strong negative correlation between, if we will try to increase the true positive, so true negative will decrease. So we have to take consideration whether the customer is more interested in true positive or in true negative. Then out of these three things, we will select the best model for further tuning. Further tuning means further hyperparameter optimization. We will check the confusion matrix. In the confusion matrix, we will see that true positive, true negative, precision, recall, all these things. Because if we have the imbalanced data set, we have to check the confusion metric. And if the data set is balanced, we can check the accuracy. So we will apply the optimization technique, which is hyperparameter tuning. So it's always important in case of machine learning. Once we have selected the model, then we have to do the hyperparameter tuning to select the best parameters. So there are two techniques for hyperparameter optimization. One is grid search and other is random search. Once we have selected the best model, then we have to prepare the automated code. So what is automated code? So in this code, we have all the algorithm. We will prepare all the algorithm. Data will be sent to all models to further training, because we have to represent this code to our senior officials, senior management, to just represent them. This model is giving this much accuracy, this model is giving this much accuracy, we have done this, we have done this. So we have to prepare the automated code. And once we have selected the best model out of, so we will generate some pickle file, and that's pickle file will be used in model deployment. So this is step number 8, which is model deployment. In the previous step, we will generate the pickle file, which is used for ML models. In case of deep learning, we will use another technique, but in case of machine learning models, we will use pickle file. So basically pickle file is a binary file in which the data is in binary form, and it's a serialization technique. I have already covered this, what is pickling and unpickling, in my machine learning video. The size of this file generally is in KB, or it can go to MB. It is having the training knowledge, so it does not require the data set. So whatever model is learned from the data, that data gets stored in the pickle file, and that pickle file is used for deployment. So we will develop the front-end API using Flask or Django. So these are the Python framework fit. So it depends whether the customer wants to deploy this model on the cloud or on the on-premises. Generally, companies are using AWS, Azure, Pivotal, Kubernetes, Docker, Cloud Foundry. Most companies are using this now these days. So once we have API is ready, so it is just like we have to pass the inputs to the model. So model will behave just like a black box. It will just take the input and it will give us the output. And whatever model is predicting, we will store in some storage, so that using that storage we can do auditing. We can do auditing like how a model is performing. After that, according to the requirements of the client, we will set up the logging and the monitoring framework. We will take the logs and the monitoring framework, whether customer want to monitor or we just want to monitor. So that will create the reports that how model is performing with the dashboard. So it will do continuous monitoring whether model is performing well or not. It is also good for us, and we can take further action. We can implement further changes in the hyperparameter. We will again train the model. It depends. We have to retrain the models in some fixed frequency. So after that, the last step is continuous improvement. Suppose the client is using this model and he's not getting good accuracy, so it will come to us and it will say model is not performing well, so we have to retrain the model. So generally it happens in 3 months or 4 months or 6 months. It depends upon problem to problem. And once we have the model is ready, then it will go to the internal evaluation. So internal evaluation basically in our organization, so our senior officials will evaluate the model. They will just give the random data to the model just to see the results, like model is performing well or not. And when it is passed by the internal evaluation team, then it will go to the external evaluation team. So client will assess the model, it will pass the random inputs to the model and will check the results, like how model is performing. And once it is passed by the external evaluation, then it will be go for the UAT testing, that is user acceptance testing. So it will done by the end user, like they will check the model, like whether it is performing well or not. So it's all about the life cycle of the data science projects. I hope this video is informative to you. Please like this video and subscribe my channel if you already not subscribed. Don't forget to press the bell icon to get the notification in inbox. Do share this video with your friends to let them know what is life cycle of the data science project. So see you all in the next video. Till then, goodbye, enjoy, happy learning.